I'm Enrique and this is Audio Technology.
Let's start off with a definition. Technology is the practical application of knowledge, especially in a particular area. And audio is the transmission, reception, or reproduction of sound. So for our crude definition, audio technology is the practical application of knowledge in the area of manipulation of sound. A common misconception is that audio technology is just headphones, amplifiers, and big audio systems. If you really want more examples of audio technology, you just have to look up. The ceiling is an example of how we manipulate sound. The ceiling's design varies depending on what you want to achieve, such as echo. Echo being the reflection of the sound that arrives at the source with a delay. The human ear can't distinguish the echo from the original sound if the delay is less than a tenth of a second. So if the average speed of sound is 243 meters per second, then one must be more than 15.7 meters away from the reflector to perceive the echo, if the reflector were to be a flat surface. An example of this roof design is located in the Center of Culture and Science of Costa Rica, commonly known as Museo de los Niños. It uses the effect of echo so that one feels inside of a spaceship. Ceilings can also be designed to amplify or focus a sound, as amplification is the natural or artificial way to make a signal stronger. For example, this roof. This same roof is using the auditorium to focus the voice of the presenter to the audience. This design emphasizes on not producing interference of the sound wave, as interference being when two waves with different amplitude or frequency interfere each other's motion. Or ceilings can also be dampers. A damper is a device that counters or dampens the effect of inertia and other forces. In this case, this design of ceilings redirect the sound so that it's more dispersed, lowering its sound level. That's the reason why several roofs are actually hollow to start with. But an interesting design here is that the ceiling has holes so that the sound seeps in easier and has a greater dampening than the previous one. Have you ever asked yourself why sound gets more difficult to hear the longer you are from the source? Well, we all know that the farther away you are from somebody, the more difficult it is to hear them. But why? We know, but yet we do not understand. Let me help you. Sound waves are usually depicted as graphs in two-dimensional ways. But we live in a three-dimensional world, so this is a representation more accurate. The reason why sound gets lower with the distance is because it's taking more surface area depending on the distance, so it's exponentially dispersing itself. If you were to record the sound level or the sound pressure, meaning how strong the sound wave is at different distances, you'll have this graph. Commonly, the sound level is measured in something called decibels, that pretty much measures the vibration the wave makes when hitting the eardrum or recording device. It can also depict how the wave compresses the air, changing its pressure. Decibels measure the amplitude of the wave, but hertz measure the frequency of the wave, and ultrasonic refers to the frequencies above 20,000 hertz. Yet, infrasonic refers to frequencies below 20 Hz, whereas the human ear can only perceive between those intervals, being the human audio spectrum. And here's an explanation to know the sound level relative to its distance.
To find the sound level relative to its distance, you want to use this equation. That means the final sound level equals to the initial sound level minus the absolute value of 20 times the logarithm of the ratio of both distances. So, for an example, if you have a conversation and you're 4 meters away, you'll do the final sound level equals the initial sound level being 60 decibels minus the absolute value of 20 times the logarithm of the ratio of the initial distance being 1 meter over 4 meters being the final distance. And if you were to solve it, would be the final distance equals 60 minus this, that equals negative 12.04. And so an average for the final sound level relative to the distance of 4 meters would be an approximate of 48 decibels. Meaning that if you were 4 meters away of an average conversation, you could actually hear it.
In summary, today we learned what's echo, speed of sound, amplification, dampers, interference, sound level, decibels, vibration, compression, ultrasonic, infrasonic, hertz, and human audio spectrum. As we know, audio technology is more than headphones and amplifiers. It can also be the design of your roof and also can be how we perceive sound. Thanks for watching.